5G mobile edge compute is poised to help federal agencies operate more efficiently and securely by wirelessly connecting a wider range of devices and applications operating over federal networks. I'm Wyatt Cash with Scoop News Group, and here to talk about that today and how 5G is helping agencies like the Department of Defense and NSA make faster and more informed decisions are Neal Ziring, Technical Director at the National Security Agency, and Wes Withrow, Public Sector Solutions Executive at Verizon. Gentlemen, thank you so much for joining us. And Wes, I'd like to ask you to start by describing what 5G mobile edge computing really is and how it's offering federal agencies a new generation of capabilities.
Okay, yes. And so let's align on terminology because these terms have kind of been used. There's some terms about 5G MEC that have been used interchangeably as they've evolved over the years. And as we talk about the new generation of operating capabilities that came with them. So 5G mobile edge compute came first, right? So it was focused on the edge of the mobile network. Think, how do I get 5G connectivity closer to the actual edge of the users and the devices and start to move that data? And then next came 5G multi-access edge compute. So that came next. And that focused on the convergence of the edge of any mobile network and the rest of the IT stack. So think of the benefits of 5G connectivity paired with compute, storage, the applications and data. So it's just really the next evolution, right? So back to the question at hand, though. So what are the new generation of operating capabilities for federal agencies? Well, it's about reducing and eliminating a lot of the overhead required to address a lot of use cases that have just been previously off limits to them, whether it was cost, complexity, or security. So for example, agencies are moving to the cloud. They may have localized data requirements that prevent them from developing or using applications that completely sit in the cloud. So during these cloud migrations, what has happened and what we've been seeing is that agencies are learning that these applications, there's many of them that perform better when they're closer to the user devices. And also agencies may have been constrained historically by data sovereignty and security requirements that require them to localize that data. So with that in mind, agencies are really opening up these new use cases for things like IoT devices, video analytics, and high performance compute at the edge. So again, it's opening up a lot of new use cases for agencies.
Well, Neal, how is 5G helping or likely to help improve NSA's ability to work with the Department of Defense and other federal agencies to better protect the national security?
Yeah, thanks, Wyatt. So 5G is going to have a lot of effects across all the topics you just mentioned, right? First, just the latency and performance characteristics of 5G are going to allow the military services, defense agencies like NSA to deploy new applications using mobile edge compute and multi-access edge compute like Wes talked about. We'll be able to put data out forward closer to the users that need it and offer them services with a much shorter turnaround time. The other aspect of 5G that's going to be very important for the Department of Defense is the improved security and authentication and network management that it's going to offer us, right? The ability to distinguish different types of devices, give them access to different services, whether it's at mobile edge compute or via network slices. And once we have that, we're going to be able to offer more flexible service. And as we'll talk about, real-time services or massive, large numbers of devices. All of that's very exciting and is going to open up new application areas for all over the DoD.
Well, Neal, I'd like to explore a little bit on something you said there, which was that about security. Can you talk about how 5G capabilities actually help agencies operate more securely?
Sure. We think that there's a couple of facets or aspects of 5G that are going to improve security, right? One is going to be improved models for authenticating the devices, whether it's a user's handheld device or a Internet of Things device or a vehicle or a robot in a smart warehouse, right? And then the next bit is that we'll be able to have 5G systems whether they're deployed as managed services or whether they're deployed as hardware, right into important areas like military bases and ports and agency facilities, where we'll be able to control and manage the population of devices and the mobile edge compute services that are offered on those networks. That's a really exciting possibility, because then we can integrate the management of those mobile networks with our cloud workloads and with our agency enterprise networks.
And Wes, from your perspective at Verizon, how else does 5G capabilities help agencies operate more securely?
Yeah, so agencies they're in the early stages right now of adopting the principles of zero trust. And they're really at this phase right now where they're designing and starting to really build their plans to implement a zero trust architecture. And one of the core capabilities of zero trust architecture is implementing network segmentation, so across the network. And we hear this all the time. Hey, if we could actually design a zero trust architecture from scratch, we'd simplify how we segmented our network out, and then we would actually focus on doing things like micro segmentation by implementing these overlay networks that are software-defined solutions, things like Secure Access Service Edge. Natively built into these 5G capabilities, and we talked about it earlier, is network slicing. And so think of the 5G network slicing as a way to carve out these logical networks that have a dedicated purpose and also dedicated security. So you can tune the security to the slice, right? So for example, one network slice may be for certain device classes that are high risk. So with network slicing, with 5G, you can do this, right? And you also have the flexibility, and this is probably the most important part about this, is you have the flexibility to quickly change how that slice is controlled. Because historically, for security and networking to be fused together and make changes to the network, it took months, years, decades. But now we're having conversations about timeframes to where you can implement these different security capabilities in minutes, hours, and weeks. So it's about security, but it's about the speed to be able to adapt security with it.
That's impressive. I'd love to hear a little bit more specifically about early practical applications of 5G that you're seeing. Neal, can you talk about examples of where you're seeing added operational or mission value because of 5G?
Well, DoD is still in I would say, pilot stages of deploying 5G to some of our military bases, but we're seeing really promising early results that I've heard about. And one of the areas that we think is the most exciting, or a very exciting area, is going to be telemedicine. Right? The low latency and high bandwidth of 5G allow you to deploy a 5G system forward with a military unit, but be able to extend medical services to them through telemedicine, giving video and telemetry and using, as Wes talked about, using network slicing to dedicate bandwidth to that application so that you can rely on it, right? That's a property of slicing, is sort of these quality of service guarantees. And we think that as that technology matures, it's going to be a huge benefit for military deployments that may have, say, an injured soldier, and he needs sophisticated medical attention that he can only get from a doctor who is not out with their unit. Telemedicine is going to save lives.
And Wes, where else are you seeing practical applications starting to bear fruit?
So let's look for the DoD specifically, right? Look at 5G-enabled drones for reconnaissance missions. You'll hear the term like C4ISR, right, which is reconnaissance. And so I used to work at a federally funded research development center. We did a lot of work with the Army. And we were developing these first theater-deployed LiDAR systems for reconnaissance on fixed-wing aircraft. So, and with human operators on it. So when we use those systems, right, we generated enough data to actually populate a small data center. Actually, that data was actually sitting on the aircraft at the time with the operators. So it was a flying data center, okay? And one of the challenges that we had was the fact that we had to land the plane when we needed to actually transmit that data that we were pulling together. So we'd have to pull these onto you. We'd have to basically be reliant on getting tethered into terrestrial platforms because we didn't have the throughput on the aircraft. And we certainly couldn't actually do anything with the overhead of security to transmit that data. So we basically had to design a flying data center. And then we had to find some unique ways to secure that data on the aircraft. And then when we brought it down to Earth, we ended up having to actually do a lot of different things to secure it there. So now fast forward 15 years today, what we're doing now is we're using unmanned aerial vehicles, drones, and they're being connected over 5G. So the low latency, high throughput, right, that was a challenge for us over these 5G networks that are now protected by cloud native security stacks. So when you start looking at unmanned vehicles, right, you're going to start to see the capability to shift a lot of things right down to the edge of those types of vehicles.
That's an impressive set of gains there. Can certainly appreciate with all the extra data that these drones are generating, that how important that is as well. Lastly, Neal and Wes, I would appreciate hearing what additional advice or recommendations would either of you offer about deploying or integrating 5G in order to see greater security benefits. Neal, maybe you could take that one first.
Okay, thanks, Wyatt. So I'd first like to foot stomp something that Wes said about integrating security with 5G with security in the cloud. That's my first piece of advice. Is anyone who's looking at deploying a 5G system should not think about it in isolation. They should think about it as an extension of their mission IT and data infrastructure, right? And where that's going to cloud. So that's first advice, right? Think about how your identities, your security controls, your zero trust architecture in the cloud, how do you extend that out to your users and your devices via 5G? The other bit I'll talk about is if you're working in a defense national security environment, you have to have good network monitoring. And so think about how you are going to monitor your 5G resources, whether it's a service that you're purchasing from a service provider or whether it's a system that you're deploying. You got to think about how you're going to monitor that, how you're going to watch for any anomalies, and then how you're going to defend it or respond. So got to think about that in advance if you're going to deploy secure 5G.
Absolutely. And Wes, your last thoughts on the matter?
Yep, Neal, and the operational aspect of it's critical. I'm glad you brought that up. One of the things, like when you start talking about integrating 5G securely into your network, you need to take into consideration how you're going to implement things and integrate them in parallel. Things like software-defined solutions, like I mentioned earlier, secure access service edge. More importantly, if you're moving to a zero trust architecture, you need to map the capabilities of 5G and the inherent security built into it with things like security service edge and do that mapping to a zero trust architecture capability model. It just helps you put a framework around it. And so think of like secure access service edge, right, as a software-defined solution that's going to act like your secure network transport that's protected by a cloud native security stack. So when you pair that with 5G, you're going to be able to map out about 80 to 90% coverage of a lot of the zero trust architecture capabilities. So now you have the ability to have a secure low latency connection, again, protected by a cloud native security stack that follows the user and the devices around. Because historically, for users and devices to get the benefits of the security stack, they would have to be tethered into a location, whereas now they don't have to be tethered in, and that security stack is like a cocoon that follows that end user and those devices around.
Well, Neal Ziring and Wes Withrow, thank you so much for taking time to share some of the new capabilities that the federal government and the Defense Department in particular and NSA are starting to really take advantage of to make their networks more secure and also facilitate the faster decision-making that comes with today's deluge of data. Really appreciate your joining us. Thank you for being with us.
Thank you.
Thanks, Wyatt.